Hello, everyone. I'm Matt Lambert, and
I'm Chris.
And I'm Ethan.
this is our project about alternative energy sources. The source that we use to create energy is hydrogen gas. Okay, so we wanted to take a look at some chemical reactions that would produce hydrogen gas and use that hydrogen gas through a proton exchange membrane in a fuel cell that would convert it into energy. So we used, first of all, to start off, we used the process of electrolysis, breaking down water into hydrogen and oxygen gas, because that's what the fuel cell needs to produce energy. So,
So what we did is we had the reaction happening in a flask, and then it would go into, and we could collect the hydrogen and see exactly the amount of hydrogen we collect. The purpose for doing this is to create alternative energy, of course, and try to find a better way to produce it, a cleaner, more efficient way. So next slide, please. Okay, so we use aluminum granules and a 6 milliliter hydrochloric acid in order to produce the hydrogen. It goes 2 aluminum moles plus 6 hydrogen moles hydrochloric acid, which then produces aluminum chloride and hydrogen gas. It produces a lot of it. We use veneer probes to measure the temperature of everything that we're using, and also we could see the amount of volume of gas that we produce through the tube, through the water, differentiating. So from the known volume, pressure, and temperature that we get from all 3 probes that we have, we can then use the Ideal's gas law to then see how much hydrogen we exactly produce. This is important for seeing how much electricity we produce from this hydrogen. So next slide. All right. So the equipment we used is a 2 flasks, one 250 millimeter for the reaction itself, a 500 milliliter flask for collecting it. The reaction between aluminum granules and the hydrochloric acid took place in the 250, and then, yeah, so I already said that. And then, when we did this, with the electrolysis, we saw exactly how much the PMC motor could produce electricity. We found the cap that it had, so we could then effectively see how much hydrogen we put into it and how much one could get out. Throughout this, we found that it capped at 75 volts, and then it would drop off. We found the exact amount that we could find in exactly one reaction that we had. So continue. So this is the data we got from our experiment. So when we look at the pressure, we see it peak when we first start it. So it peaks once and then peaks again, and then it caps off and goes back down. The temperature, however, grows steadily. This is because it's an exothermic reaction, and it is pretty important to see this so we can find exactly how many moles. So we used the ideal gas law that we said before, and we found that we produce exactly 1.07 moles of hydrogen. The heliocentrus device gave us, we plugged it into it, and we used the exact amount of hydrogen, and it showed that it gave us 0.42 volts and 0.11 amps. So this is our acknowledgement page, but we can tell exactly how effective this is. We get a production of aluminum chloride, which is something that can be used.
It's used primarily as a salt. It's usually used for medical uses. I'm
kind of vague on the exact purposes. It's been a little while since I've read it, but the point is that we're not creating any waste from this experiment. We're not actually with a whole lot of other experiments you have, well, not experiments, with a whole lot of other reactions used to create electricity, you get byproducts that are either unhealthy, bad for the atmosphere, or give off large amounts of radiation. With this, it's kind of like killing two birds with one stone in the fact that, one, we're increasing a medical product that can be a medical product while creating hydrogen to be burned for electricity or possibly other uses. That's all.
Thank you.